So now that we've talked about the use of then apply async in the context of the download image async method, let's go ahead and talk about other uses of completion stage methods in the context of the apply filters async method. So here's where it occurs. You can see that we would have a stream of completable futures to optional images, and then flat map gets called. And if you recall, flat map is the one that flattens the behaviors, the output in this case, and we're going to call the applyFiltersAsync method. And that will asynchronously filter the images, in other words, apply the transforms, and then store them into the files. As before, we simply ignore the empty optional images. What's significant about this particular behavior, applyFiltersAsync, is that it takes a single image and applies multiple filters to transform that image. So let's say, for sake of argument, that there are 3 transforms to be applied by this method. So in that case, you get 1 image in, and 3 transformed and stored images come out. So if you had, say, 10 images you were processing, you'd end up with 30 images coming out of this. Now, if you recall, map always has to give back the same number of elements in the output stream as came into the input stream. So that would be awkward because you would have to use some kind of other structure like a list instead of simply completable futures to optional images. So instead, we're going to use flat map so we can end up with more images coming out of this method than we had coming in by however many filters are called to transform the input images. So that's what flat map does. Flat map will return the stream of completable futures to optional images, which will have a value if the image is being filtered and stored, or will be empty if it was already cached. So that's the same behavior. We're just ignoring stuff that was empty all the way down the chain. So here's applyFiltersAsync. This is the most complicated of the various stages in our pipeline because it has to do a bunch of different things. What it does is it takes the list of filters and converts them into a stream of filters. So let's say, for sake of argument, we have 3 image filters we're going to apply per image. It might be like, emboss, sharpen, blur, for sake of argument, and or grayscale, or whatever you want to put there. So now we're going to have a stream of filters, and for each filter in the stream of filters, when the image finishes downloading, then asynchronously apply some action. So that's what's going on here. This action, which we're going to talk about in a second, only gets applied when image future has finished. So only after we finish downloading everything. Here's the action. This is going to take the image optional, and if there's a non-null value, if there's actually a value present here, because we actually downloaded the image, in that case, we're going to apply this particular behavior. And the behavior is a factory method that says make filter decorator with image. So this is going to go ahead and make something called a filter decorator, which takes the filter, connects it to the image, and then runs that behavior. And that run call, which is a synchronous call, occurs in the context of then apply async. So this, of course, only gets called if there is a valid image. And this will then get called asynchronously in the context of supply async. And as before, then apply async is called using the executor that's returned from the getExecutor helper method, and that, of course, is the common fork join pool. So that particular filter will be called, and the filter decorator will go ahead and apply the image transform and then store the result into the file system with the appropriate name. And that all takes place asynchronously. Now, this is kind of interesting. You can see here that then apply async returns a completable future. And that completable future will be triggered when the image has finished being filtered and stored. And so what's coming, so you can see here that we're going to have a completable future. But what's really interesting is there is no terminal operation here. So what we're going to get back is a stream of completable futures to optional images. So that, again, there's no terminal operation. So a stream is returned. So what that means is that this processing does not take place until we reach a terminal operation in the next phase of the pipeline. So you can see here we're going to end up with this stream of completable futures to optional images that are in the process of being downloaded and transformed, and stored. And we only have one stream of these things because it has been flattened by using flatmap. And of course, this whole thing will be processed by collect, as we're going to talk about in the next lesson. One of the things you probably are noticing at this point, especially if you were to go back and re-watch the videos we talked about earlier, where we did the parallel streams variant, is how much more stuff is taking place under the scenes here. And that's because all the processing is being done asynchronously. And it looks a little complicated, and it honestly is complicated, but luckily the Completable Futures framework provides us a lot of structure, and of course the stream that we're using helps to organize the different stages in the pipeline to keep the whole thing manageable.